What you are looking at is not a rock. It is not a piece of coral or the random refuse of the ocean floor. It is a tomb containing the ghost of a genius mind. For 2,000 years, this object lay buried in a Roman-era shipwreck. When divers found it in 1901, they brought up priceless bronze statues, marble sculptures, and amphorae. And they brought up this, a calcified, corroded lump of bronze fused into an unrecognizable mass. It was cataloged and ignored, but this lump held a secret that would rewrite the history of technology. Inside this corroded shell was a computer, a clockwork universe of breathtaking complexity, a machine that shouldn't exist for another 1,500 years. This is the story of the Antikythera mechanism, but more importantly, this is the story of how we decoded it. It's a scientific detective story, a high-tech investigation using 8-ton scanners and 3D imaging to look inside the corroded fragments, read the invisible text, and resurrect the single most sophisticated piece of technology from the ancient world. We are going to peel back the layers of time, not with a chisel, but with high-energy X-rays. Our story begins in 1900. A team of Greek sponge divers, blown off course by a storm, took refuge near the island of Antikythera. When the storm calmed, they dived. They didn't find sponges. They found a ship. The Antikythera wreck was a Roman treasure ship lost around 70 BC. It was a time capsule of Hellenistic wealth. But in 1901, the real treasure was mistaken for junk. It was moved to the National Archaeological Museum in Athens, and there it sat. The first breakthrough, our first act of decoding, came a year later in 1902. A museum archaeologist, Spiridon Stice, was examining the 82 fragments of this lump. He noticed that one piece had split open, revealing something impossible, a gear wheel, a perfectly formed triangular-toothed gear. This was the first anomaly. This was the first breadcrumb from our 2,000-year-old genius. Historians were baffled. The level of precision engineering, small, complex gears was not supposed to exist in 70 BC. This kind of technology, this gearing, belonged in the great cathedral clocks of 14th century Europe. A puzzle was born. What was it? For 50 years, scholars debated, was it a clock? A navigation tool? But the mystery was locked tight. The mechanism was a 3D jigsaw puzzle, but every piece was rusted shut. It was physically impossible to take it apart without completely destroying it. Imagine trying to understand a Swiss watch by smashing it with a hammer. That was the problem. The machine's secrets were sealed by the sea. The next great decoder was Derek J. DeSola Price, a historian from Yale. In the 1970s, he brought the first piece of modern technology to the fight, 2D X-rays. The results were foggy, haunting, but Price saw for the first time the ghosts of the machine. He could count the gears. There weren't just a few, there were dozens. He identified a large central gear, likely for the sun, and another for the moon. He also discovered faint Greek inscriptions, letters, a manual. Price proposed a revolutionary theory. This was an astronomical calculator. It modeled the cosmos. But 2D X-rays have a fatal flaw. They are flat. They flatten a 3D object into a 2D pancake. Price could see the gears, but he couldn't see how they meshed, which gear sat on top of which axle turned which neighbor. He had found the table of contents, but the book itself was still unreadable. The internal structure, the true genius of the design, remained a black box. The 20th century had hit a wall. To go further, we would need to see the impossible. We would need to see inside. Enter the 21st century and a new team of decoders, the Antikythera Mechanism Research Project. This international team of scientists, astronomers, and archaeologists knew they needed a new weapon. If 2D X-rays were like a single photograph, they needed a CAT scan. But you cannot take a priceless, fragile 2,000-year-old artifact to a hospital. So, in 2005, they did the opposite. They brought the hospital to the artifact. Their weapon was a machine custom-built for the task. They called it the Blade Runner. This was not a medical scanner. This was an 8-ton, 450 kilovolt beast of a machine designed for high-power industrial scanning. It was so large, it had to be assembled inside the museum's basement. This is where the real decoding begins. Here's how it works. A standard X-ray gives you a shadow. A computed tomography, or CT scan, takes thousands of X-ray slices from every conceivable angle. A powerful computer then stacks those 2D slices together to build a perfect, high-resolution 3D digital model. For the first time, the team could do the impossible. They could digitally disassemble the mechanism. They put fragment A, the largest piece, inside the machine. They hit the switch, and they waited. What emerged from the data was beautiful. The corrosion and calcification vanished. The digital model was pristine. They could see every gear tooth. They could see axles, pins, and slots. And they found the machine's hidden genius. Inside fragment A, they found a system that shocked them. It was a series of gears riding on other gears. This is called epicyclic gearing, or planetary gearing. Why is this a big deal? Because the sun and moon don't move at a constant speed across the sky. They speed up and slow down. The Greeks knew this, but modeling it mechanically, that's genius. The Antikythera's creator used a pin and slot mechanism driven by these epicyclic gears to perfectly replicate the moon's variable motion. This was a level of mechanical theory we thought was invented by Ptolemy centuries later or implemented by clockmakers 1,000 years later. But the machine was just getting started. The CT scans revealed the back of the mechanism. It wasn't just a simple calendar. It featured 2 large spiral dials. One was the Saros dial. This 223-month spiral was an eclipse predictor. It showed when a lunar or solar eclipse was likely to occur, and even suggested the color of the eclipse. The second was the Metonic dial, a 19-year, 47-division calendar, which was the standard civil calendar of the Greeks. But the CT scan found a smaller, subsidiary dial inside the Metonic spiral. This was the human connection. It was an Olympiad dial. It was a 4-year dial tracking the schedule for the Pan-Hellenic Games, the Olympics, the Isthmian Games, the Pythian Games. This wasn't just a tool for astronomers. It was a desktop companion for a wealthy Greek philosopher. It connected the motions of the heavens with the cycles of human life. The CT scan had revealed the machine's purpose.
The gears were only half the story. The decoders knew the mechanism was covered in text, but most of it was gone or hidden inside the fused fragments. Price had seen letters in the 70s, but now the CT scanner could read through the metal. The 3D X-rays revealed thousands of new hidden characters, text that hadn't been read since the day the ship sank. But there was another problem. The surface inscriptions were too faint for the CT scan. They were just textures on the corroded surface. For this, the team used another piece of 21st century magic: polynomial texture mapping, or PTM. A PTM device places the fragment under a dome with 50 light sources. It takes 50 photographs, each with the light coming from a different angle. A computer then combines these images. This allows the operator to move a virtual light across the object on a screen. As the light moves, the shadows shift, and letters, inscriptions, words jumped out from the corrosion. They were reading the instruction manual. The text was a revelation. It was a philosopher's guide to the cosmos. A newly discovered section on the front of the machine described the cosmos with the sun, moon, and planets. It wasn't just a machine, it was a teaching tool. The text confirmed the planets. It described the wanderers: Mercury, Venus, Mars, Jupiter, and Saturn. This discovery triggered a race. Now that the decoders knew what the machine was supposed to do, track all 5 planets, they had to find how it did it. This was the final piece of the puzzle. The CT scans had revealed the gear counts. The inscriptions confirmed the planets. Now, a team from University College London in 2021, led by Tony Freeth, who was a part of the original 2005 scan team, put all the evidence together. They used the CT scan data to reverse engineer the machine's gearing. They had to figure out how one single crank input could drive all these complex, different cycles. The math was staggering. The Greeks had to find the lowest common multiple for the complex orbital periods of all 5 planets. The UCL team proposed a new model, a brilliant, elegant system of nested pin and slot gears that fit perfectly within the known dimensions of the CT scans. It was a system of such sophistication that it accurately modeled the complex retrograde motions of the outer planets. The decoders had done it. They had rebuilt the machine, gear by gear, using light and data. They had resurrected the ghost.
So we stand back and look at the completed puzzle. What have we decoded? We have decoded a mechanical cosmos, a computer from 70 BC that did not just track the sun and moon. It predicted eclipses. It managed civil and athletic calendars, and it modeled the bizarre looping paths of all 5 known planets. It was a microcosm, a philosophical machine that placed the user in the position of God, able to see the past, present, and future of the heavens with the turn of a crank. The decoder's tools, the CT scanner, the PTM dome, answered almost every how, but they also raised the 2 biggest questions: who and why? Who could have built this? The scans cannot give us a name, but the location of the shipwreck and the style of the text points to a Greek workshop, possibly on the island of Rhodes. This was the home of the great astronomer Hipparchus and the Stoic philosopher Posidonius. Was it a genius taught by Archimedes, who was known to have built simpler mechanical spheres? We will never know the name, but the scans prove they were not a lone tinkerer. This was the product of a mature, sophisticated tradition of engineering. Which leads to the final, haunting question. If they could do this in 70 BC, why did it vanish? Why did this technology disappear for 1,500 years? The decoders have a theory for this, too. The machine was expensive. This was not a tool for the masses. It was a bespoke masterpiece for a king, a philosopher, or a wealthy merchant. The knowledge to build it was likely held by a very small elite group of master craftsmen. And then, Rome fell. The Dark Ages began. Libraries were burned.
Intellectual traditions were shattered. The fragile chain of knowledge, passed from master to apprentice, was broken. The genius who built the Antikythera mechanism simply died, and no one was left who knew how to make another. Technology is not a guaranteed forward-moving line. It can be lost. The only reason we know this technology ever existed is because this one single example, this ghost, was lost in a shipwreck before it could be melted down or destroyed. And it was found 2,000 years later, just as we, the decoders, were finally inventing the technology advanced enough to read it. The Antikythera mechanism is not a story about ancient aliens. It is a far more powerful story. A story about the staggering, almost lost potential of human ingenuity.